Hey everyone. Today let's look into the LeetCode problem 167. To sum 2. Input array sorted. So let's first try to understand the question here. Given a one indexed array of integers, so basically it's indexed from 1, 2, 3 onwards rather than 0 indexed. Okay, numbers that is already sorted in non-decreasing order. So basically it's sorted in the ascending order. Find two numbers such that they add up to a specific target number. So as you can see here, for example, 2 plus 7, which would add to target 9. Let these two numbers be numbers index 1 and numbers index 2, where 1 less than or equal to index 1 less than index 2 less than or equal to numbers dot length. So you can see, right, basically we should have two indexes within this number, which would find within this numbers array, which would add up to the target. Let's read this question completely. So one critical point is this is sorted. Okay, return the indexes of two numbers, index 1 and index 2, added by 1 as an integer array of length 2. Basically it has to be one indexed. The tests are generated such that there is exactly one solution. You may not use the same element twice. So basically you're not expected to use the same element twice. So you should have two unique indexes, index 1 and index 2. Then your solution must use only constant extra space. So this is a very critical point, because there's another way, think this way. One way to solve this problem would have been that, hey, I just keep these in a hash table and ensure that whenever I find a number such that 9 minus, for example, I just keep 2, 7, 11, 15 in a hash table, and then whenever I find a number such that 9 minus 7 gives 2, then maybe I could have used that one. So that's one approach, but the problem is that would have taken an order of in space complexity. Another way is basically go through each and every element and see whether we find a combination. Okay, but there also this time complexity will be higher. So when I mean, let's see how to solve this, right? So the thing is, imagine that I wanted to have an order of 1 space complexity solution. Okay, solution. Let me make it a little bit bigger. Okay, so space complexity solution. Okay, so one approach would be that, hey, I just take 2 and my target element is 9. So I just I take 2 and then go through each of the remaining elements and find a combination where it hits 9. So maybe like start with 2, search for all the remaining elements, then start with 7, look for all the remaining elements, and so on. But if you see, then also the time complexity will be order of n squared in that case. Okay, so now the critical piece here is the numbers are sorted. So this is what property we can use. So let's think about an approach which would give us a much better time complexity. And especially this problem is a medium, so you're not expected to give an order of n squared or a brute force solution here. So one approach that we can think of is, let's see, start with the start pointer, with the smallest element and the largest element. Okay, now if I sum this, then that would give me a number which is greater than, so if you sum these two, it will give me 17. Now that means this overall sum is greater than 9. That means with 15 you will not be able to get the sum 9. So now we can actually move this right pointer one level down. Okay, and again now take a sum. Now you can see that the sum is greater than again 9. So that means with this number we will not be able to reach 9. So now again reduce the left pointer. So what will happen is, now this would give us the answer. So now let's see how to code this up. If, for example, if this was a, let's take another example, right? I'll take an example from here itself. Yeah. So let's take this case. This case is also 2, but let's put something slightly different here. Let's take a case of this way. Okay. And let's assume that we need a sum of 6. Now, if you see here, if I start with my left and right pointers the same way, now when we start, 1 plus 4 would give me 5. So that means the total sum is less than the expected target sum. So in that case, that means with this 1 we will not be able to reach the solution. This will be the maximum value that we can achieve with this 1. So that means we could actually move the left pointer by 1 and see whether we hit the number. And as you can see here, it is a 2 plus 4, which is 6. Now, so basically it's a 2-pointer approach. Let's see how to, now let's code this up. Okay, let's start here. Okay, so let's take int, I'll take 2 pointers, L is equal to 0 and int R is equal to numbers dot size minus 1. Okay, then while L less than R, because need 2 unique indices, so it cannot be equal, L and R cannot be equal. So now if I try to solve this, I'll just take the sum. Okay, as explained earlier, I'll just take the sum. So this is numbers dot numbers of L plus numbers of R. Okay, if sum equal to basically our target, then that means we found a solution. So we could just return L comma R, but we are expected to give a 1 indexed array. Okay, so 1 indexed array, so we will give it as L plus 1 and R plus 1. Okay, then if we come to else if sum greater than target, then that means we have a with that particular R index, similar to this case, right? R index, we will not be able to reach that sum, target sum. So we could just make R minus minus. Okay, else basically a case where like this, for example 1, our left pointer being in 1, and if we sum it, it is less than the total target. So with this 1 we will never be able to achieve that target. So this is the case, and if we are not able to hit any use case, we are expected to return -1 pairs. Now let's just see, this should be having a time complexity of order of n. So our time complexity should be order of n, and our space complexity, as you can see we are not using any extra space, should be order of 1. Okay, so let's just run it. Let's run it. Okay, so you can see it. So that's it for today. Thank you.